Thanks for coming in. Pretty amazing stuff we're seeing here. I want to give you a little bit of perspective, though. One of my favorite quotes is this one from Edwin Schlossberg. If you've heard me talk, you've probably heard it before. The skill of writing is to create a context in which other people can think. That means that the way we talk about things is a kind of map. And like any map, it can either take us to the right place or it can lead us astray. So I want to talk a little bit about some of the words we use in the current context and start thinking about what we might be missing. So I did a word cloud of the Internet of Things article on Wikipedia, and obviously you see things is a really big word there, and not only that, devices, objects, so on, appear a lot. And sure enough, there are some pretty amazing smart things. That's that last word I circled down there. You know, like out front, you probably saw the Tactia smart router. I mean, I'm a home craftsman. I go, I want one of these. You know, I'm not as good as I'd like to be, and this thing would make me better. It's a human augmentation. It's just super awesome. You know, the one wheel, I tried it yesterday, not very well, but it's pretty awesome. You know, so, and of course the Makani airborne wind turbines using incredible smart control to generate power. This is actually an invention originally of my son-in-law, Saul Griffith, so I'm very proud of that. But there's something missing in this word cloud, because it isn't just smart things, right? It's also people and time are really some concepts that are in there, and they're way, way too small. And I think one of the things I'd love to have as an outcome of this talk is that the people in this room go read that Wikipedia entry and make it better, because I don't think it actually captures so many of the concepts that we need to be thinking about today. So I want to talk a little bit about these aspects of people and time that are too small in that graph. So when we think of the Internet of Smart Things, we tend to imagine that these things, you know, the Nest thermostat or the Google self-driving car, they're sensor and data-driven, they're autonomous, there's not really human input, and they're kind of operating in real time. And that's sort of like our sort of first blush imagination. But in fact, you know, one of the super interesting things about the Google self-driving car is its connection to the human-driven Google Street View vehicle, which did actually all the initial mapping. And so what you see here is actually humans and machines operating together in a really, really interesting, complex pattern in which data is captured through human activity, stored in the cloud, pre-processed, and then used by a robot. And I think that pattern is a really, really important one to pay attention to as you design applications. Think about how data generated by humans is captured over time, is stored, and then acted on later by a device. It's not all real time. You know, so the human input is critical. The human input may also be implicit rather than explicit. So when you see the web page for the Nest learning thermostat, you know, the whole pitch is that it learns implicitly from you. But it also learns explicitly. You set the temperature. By the way, Nest, you've really got to show more energy-friendly temperatures in your advertisements. But you know, it auto-detects when you've been away for a while. Okay, that's sort of our image of the smart thing. But we got to remember that we are still giving that input. It's just through a different kind of interface. You know, we're so used to talking about we give input through a keyboard, and then we got into, wow, we're giving input through a mouse, and now we're giving it through a touch screen. This is still user input. You know, when we basically don't show up in the room, that is user input to this device. So think about this as a user experience problem and not an autonomous device problem. And of course, you have interesting things because there's a Nest app. And one of the things I've noticed is that once I set the schedule using this app, the device doesn't seem to learn anymore. So the interaction between the explicit, the implicit, what modes of implicit really matter. Also think a little bit more broadly about the kinds of sensors that you have. You know, the ones that we don't use that often sort of seem magical. But some of the most important sensors that we have around us are the camera and the microphone in our phones. And both Siri and Google Now are using the microphone as very, very powerful new interfaces that are going to get better and are going to be a big part of the user interface mix for this Internet of Things. So, but the point is, sensors allow us to create new kinds of user interface. But you still got to remember that it is a user interface. And I have an example of one that's a bad user interface, and that's this wonderful little smart key for my Tesla. And it does wonderful things like I walk up to my car, the car automatically opens. I don't have to stick it in a little slot, turn it, do any of those things. But it's got one really bad flaw, which is all over the forums, which is it can't hang on a key ring. And I go, that's actually a stupid device, because it didn't think about how I might want to use it. And every time if I leave my car in valet at the airport, it comes back in a little plastic bag because they can't hang it on the hook. Sometimes they lose it. The entire system in which we operate is the user interface. There's this great sticker that this is, you see I've actually taken one from the sheet, was given to me by Liam Maxwell, who's the CTO of the British government. And they've really focused very hard on this idea of what is the user need. And they made that the first of their design principles, start with needs. And I think all of us, as we design this new world, have to think about user needs first. And so kind of coming back to this Internet of Things thing, I also want to move on and pick out another one of the big words that we use, and that's Internet. And the Internet really matters. When you look at that smart device, it's not a standalone device. Yes, it's controlled by its smartphone, and yes, Nest now has other devices, and they're connected in a network, and they talk to each other. And in fact, all of these things, are connected to, satellites, to data centers, potentially to other similar devices or other smart devices. By the way, and even in that data center, you've got actually smart network of things. The cooling is controlled, autonomous, semi-autonomously, so on. So there's this big network all over, and there's a network of data centers all over the world. So Internet is very clearly involved. But let's remember the original ground rules of the Internet. We used to call it the network of networks, because it was this magic thing that connected all these incompatible networks. And interoperability was the focus. And one of the things I worry about as we move into this new world is we may have forgotten that interoperability. We have vendors who are trying to own it all, building these systems that talk to their devices but not to everyone else's. So we have to think a lot about interoperability. And we have to think about this wonderful principle that was put out by one of the saints of the early Internet, John Postel. I wonder sometimes what would happen if he hadn't died too young of a heart attack. He wrote in the original TCP RFC, be conservative in what you send, be liberal in what you accept from others. It's been known as the robustness principle. Actually, not the original TCP RFC. It was a version of that early RFC. And that's such an important principle, and I want those of you who are designing devices, designing systems, to think about interoperability and to remember, if we really want it to be an intranet as opposed to a set of intranets, you've got to think about interoperability. The next thing I want to hit briefly is this notion of software above the level of a single device. This is a phrase that I got from a guy named Dave Stutz, who wrote this fabulous letter when he left Microsoft back in 2003. And it was sort of his parting advice, and it ended with the line, useful software written above the level of the single device will command high margins for a long time to come. It was very, very prescient, because a lot of focus was still on the PC, and even on the network, it was like very, small thinking. And this notion of software above the level of a single device stuck in my head. I've used it for years. It was part of my core Web 2.0 principles, think of. But I want to bring it out in an example like the Uber app, right? Because here's actually a smart things app. Again, we forget that the phone is our most widely used smart thing. Let's not get too taken up with new wearables. This thing that we carry in our pockets is filled with sensors. It's filled with capability. It's a key component of so many of these things. But what's really interesting about Uber is, of course, it doesn't work in isolation. There's an app for the passenger, but there's also an app for the driver. And those two things are coordinating in real time using a kind of internet operating system. There's various kinds of functions for communication, for GPS to locate everybody, to track progress. So it's a payment, a rating system. All these things kind of are part of a system of interaction. That's a wonderful phrase that was coined by someone at IBM. And what I want you to think about here is that once you have new UI capabilities and new augmentations of humans via sensors, you can actually start to think about things differently. And there's this wonderful quote from Aaron Levy of Box that I got on Twitter, where he said, "Uber is a lesson in building for how the world should work instead of optimizing for how the world does work." And that's our opportunity with this new technology that we've been given. We can start thinking about how the world should work instead of optimizing how the world does work. So back to that Makani wind turbine out there. The idea that instead of having a turbine sitting on the ground like we've had since the days of Dutch windmills, you could actually put one in the sky using this incredible control technology, which, again, they're still working on it, but the notion that this thing has to be able to fly autonomously for thousands of hours, has to be able to take off and land by itself, and it's generating power up high where there's always wind. That's thinking about how the world should work rather than how the world does work. So that notion is critical, and the sensors let us do new things. Company that we're invested in at O'Reilly AlphaTech Ventures, Cover. By the way, if they've just arrived in San Francisco, if you use the code @TimO'Reilly, I think you get a little free drink on me. So download that and try it. But again, same kind of thing. Because you're registered with the cloud, because the application is able to tell where you are, you can walk into a restaurant, sit down, you're identified. Effectively, when you're done with the meal, you walk out, and your credit card is charged. It's kind of magic. We can rethink how things work. Another great one, make space, your closet in the cloud. This is one of my points about sensors don't have to be complicated. These guys have realized that if you actually can take pictures of what you put in the boxes when you put stuff in storage, and you can identify what's in that box, you can actually put this stuff away in a warehouse, where warehouse space is cheap. They can bring you just the box you want. You don't have to go rooting through your storage closet, because effectively this can go into a modern, effectively, robotic warehouse. It's pretty awesome how rethinking the process because you have new capabilities. And so where I want to go with this is a final piece of advice, which is don't just try to recreate the experiences and the technologies that we have today. Try to think about new things, and in particular, think about things that seem hard, that might have seemed impossible before you had these new capabilities. Because one of the things I'm most excited about in this technology revolution is it is really giving us amazing new capabilities to affect the physical world. And the physical world, in the end, is where we all live, and where the biggest problems that we face as a society are to be found. We have to feed the world. We have to generate energy. We have to deal with climate change. We have to deal with the problems of our society. And there are amazing new capabilities, and I want you not just to make cute, cool, amazing consumer devices. I want you to think about hard problems that you can solve, take this technology, and make the world a better place. Thank you. Now,